So you guys have gotten your notes set up for Chapter 10b. Just a couple sections we're covering before Chapter 10b quiz to finish off Chapter 10. Up at the front, or up at the top, you were graphing in function mode, plain old y equals, but you would have had to definitely play with your window to make it look like that. And then down here in the bottom, I've let you know there's another mode that you need to go into called par mode. And when you guys go into par mode, it's definitely going to look different. You're not going to have the normal plain old y equals that you've had all along in function mode. Well, we did go out of function mode once. Do you guys remember when we changed the mode out of function mode that one time? Sequence mode, good, when we were doing sequences in series. Remember in sequence mode when you hit the X button, it wasn't an X anymore? Do you remember what it was? It was an N? Yeah. And if you think about your calculator, in this mode, it was the far right-hand mode on that whole list. Par is in that same line. And N is the far right letter on your variable button. So maybe par mode, which is the second one, maybe it matches up with the second variable on the button, which would be a T. Which would be a T. Okay, par mode. You guys playing with your calculators yet? Oh, a couple more seconds. When you finish writing this down, go to your calculators, hit the mode button, change from func mode to par mode, from function mode to parametric mode, and then put in the equations that you see. Yeah. Well, kind of. If you hit the y equals, you're going to see things look a little bit differently. So try to put them in the right spot according to what you see. I just turned up the air, so it should get a little bit warmer in here. Maybe listen to the video. So sorry. Just put on a sweatshirt. Okay. Let me get out my calculator. Make sure that's good to go. I think I had to change it for calculus last class. So, ooh, I don't even have my calculator out. Okay. You guys seen what I mean by things looking a little bit differently? As I'm getting my calculator up, I think I actually might have cleared out the original function mode graph. So I might need your help just a little bit as far as the window. When you put in the negative x squared over 72 in function mode plus x, let me check it. Oh yeah, I definitely cleared it out. Okay, when you put that in, question, how did you guys play with the zoom to make it look like what you saw? Zoom out? Zoom fit? Zoom standard? So that's kind of all the different zooms. Let me hit zoom standard first. Zoom standard. Doesn't look like the picture. I want you guys for the remainder of this page to be thinking of, ready? Launching a water balloon. I want you to think of launching a water balloon. Have you ever seen those big old slingshots where you have to have two people that are like holding the handles? And then there's like the little pouch for the water balloon to go in, and then there's a guy who's pulling it back as a slingshot. The water balloon's right there. It's a launcher. They pull it all the way down as low as you can go, and then you shoot it up. No? It's a good one. It's a good one. Think of slingshot. Slingshot where you just pull back and you let it go, right? And it shoots out something. It's like that, but it's a big slingshot. So there are two big handles. Two people need to be holding it. One here, one there. Then someone in the middle is pulling back with the water balloon. They launch it, trying to, I don't know, hit a target, hit someone on the other side. I want you to think of launching a water balloon. Okay? So pulling it back all the way to the ground. It starts in the ground. Then it goes up in the air. Then it comes down and hits the ground. Now, we're going to try and play with our window to make it look like that, first of all. Okay. So you guys thought zoom out. All right, it's a good idea. I think it's too zoomed in, so zoom out. Dun, 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 dun. Well, some of you guys thought zoom fit. Okay. Dun, 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 dun. It paused for some reason, sorry. It's still paused? What are you doing? Go. There we go. Not quite. Well, I guess I could zoom out some more. Maybe I should just play with my window. Did anybody figure out how high you should go? Or how far? 80? Okay, 80 seems to get that full arc. And then I think at least a little bit higher, right? Maybe 20 should be good? Okay. Now let's try. Dun, 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 dun. That's pretty good. I mean, we could go a little bit further if we wanted to. We could go to like, I don't know, 100 maybe, just to get the full arc. But either way, if you're thinking about the slingshot example, well, do we even really need this lower part? Why not? Is the slingshot traveling from the center, or the water balloon from the center of the earth and breaking through the ground and shooting up and then going back down into the ground to the center of the earth? No, that makes no sense. Is this parabola good? Yeah. Could I figure out when the parabola is at the very top of its motion? Or I should say, yeah, when. When the parabola is at the very top of its motion, how high in the sky it is, how high in the air it is, and how far it is? Yeah, can I figure out when or at what value the water balloon will hit the ground, like how far down the field? Yes. But it's not very realistic in that it's graphing this whole parabola that isn't even a part of my example. My example starts here and ends here. What do you guys notice about this graph down here? Huh. It seems like it starts and stops. Now, sometimes you're like, okay, well, I could do that. I could erase it and say, look, it starts and stops. But maybe the calculator starts and stops it as well. So, okay, hold on. We were going to mode. We were changing it to par. Second mode, right? Second one over as far as this line of code. If I can get it to go over, par. When you guys went to your y equals, what did you notice that was different? Did anybody try to just graph one? You can try. I mean, to try, you'd have to erase out the other one. But if you try to just graph one, guess what? It's not going to work. And here's why. There's one graph for these two. And there's another graph for these two. And there's another graph. You need parametric equations come in pairs. You need two equations to be able to graph. Because parametric equations say, okay, we're going to totally separate x and y and say, let's just deal with the x's, the horizontal stuff. Let's deal with the y's. Let's deal with the vertical stuff. Totally separate. So, one quick thing that could have gone very, very wrong. Can you guys make sure you did not put the t under the square root? That could have messed things up. It's very easy to get the t under the square root. Make sure you hit the over button. The t has to be outside of the square root. The square root was just with the coefficient, not with the t. Okay, as long as you have that written down. Now, if you want to reset everything, well, kind of have a good window. Maybe we should just go for it as is. Graph. That's interesting. It's kind of cut off. Where does this seem to be starting, guys? Yeah, it seems to be starting at the origin, which is nice for our example because the slingshot, the water balloon didn't even launch until I let go, or the person pulling it back let go. So this is kind of more real life in that it lets it start at the beginning and not start like way back in the time before the scenario even began. Because at the very beginning of the scenario, the water balloon was on the ground in the launcher ready to be launched. But here's the problem. When does this not get very practical? Still goes negative. Well, let's see. My x's got the horizontal, my y's got the vertical. Let's go check out that window and figure out what's new, what's different. When you hit the x button, you guys already should have figured out a t pops up, right? And because there's this new variable t, which in their notes you already called a parameter, there's not just going to be x min x max or y min y max, there's going to be t min t max. Now, do you think the x's made the graph stop or start? Do you think the y's made the graph start or stop? As far as when to begin graphing and when to end graphing? Probably not, because the x's and y's were there in function mode. What's new? What's different? T's. So, What if we were to do, I don't know, 0 to 1? Let's just not let the t's go very far. 0 to 1. What do we got? Oh. What do you think t stands for? Time. You're exactly right. So if t is time, let's just say, for sake of the example, let's just say that time is being measured in seconds, and we're doing our water balloon example. So after 1 second, where's our water balloon? Still up in the sky. How do we get to come back down? Let more time pass. So I don't know, what do you guys think? Go to 2 maybe? 3? Okay, let's go to 3. Oh, too far. Okay, go back. Let's do 2. Wait, this is silly. Hold on. We know how to find zeros. How do you find zeros with your graphing calculator? Perfect. We've been doing it since the beginning of the year. We're in a new mode, and with a new mode comes new menus, and with new menus, things disappear, like maximums, minimums, intersections, and zeros. So if it's gone, I guess we just keep going with what we're doing. Now we could use that cool value thing, and we could say, well, okay, we tried 3. 3 was too far. We could try something like 2.5 and say, hey, where are you? Oh, you're still down. Okay, forget that. There's a shortcut for the value. Just hit the trace button and jump to, oh, what about 2.2? Oh, you're still past the ground. But we could kind of guess that way, right? We could go ahead and go to our table even to be guessing points, and we could do things like, hey, 2.1, 2.11, 2.2, 2.12, 2.125. What was I doing? I was playing around with different values close to 2, saying, when do you hit the, ooh, you hit the ground in between 2.1 and 2.2. Okay, then I started zooming in on 2.1, 2.1 and 2.12, positive, positive. There's a change in sign, intermediate value theorem. So I knew it had to happen somewhere in between here and here, but isn't this kind of tedious and annoying? Like trying to figure out what's going on. Why am I only looking at the y's and not the x's? Why do I not care about the x's, only the y's? What am I trying to find? When this guy hits the ground, right? So if I was looking at my graph, and if I did do something like, for instance, if I was like, oh, hey, 2.1, I bet that'll do it. And then I graph, ooh, that's not going to work very well at all. Just kidding. Coming back. Starting at 0 and going to 2.1. Let's say I guess that as my 0. And I'm like, it hit! What's the dilemma? First of all, I have way too many tick marks on my x-axis. I'm going from -40 to 100, trying to fit in all those tick marks. Thank you. Maybe I should go by 10s instead, just to make it look a little bit nicer. Oh, there we go. Oh, it still hit. Well, are you sure it hit? I'm almost there. Huh. Okay, let's see. Does it hit? No! Struggle. When does it hit the ground? When will the water balloon hit the ground? When the what is 0? When the y is 0. X, I don't care. It's gone down the field somehow with me launching the balloon. X is something, it looks like 72-ish. But y is 0. Wait a minute, hold on. I'm doing all this work just to make y equal to 0. I'm trying to look in my table. I'm trying to look in my graph. I'm trying to change my window. If all I care about is y being 0, what could I have done way back here? To hit the ground, y is 0. Can't I just use math? Now some of you are like, oh, that's disgusting. I have to use the quadratic formula? There's only 2 terms, not 3. How can we factor this guy? We could subtract. The other way, just because factoring is usually the better way to try to go first. Factoring out of t, and I get -16t plus 24 rad 2. If I'm solving for zeros, couldn't I just set each one equal to 0? So t equals 0. Oh, I know that one. Haha, it was on the ground to begin with. The other one would be Subtract the negative 24 rad 2, divide by negative 16. 24 rad 2 over 16 is 3 rad 2 over 2. Someone plug and chug it to your calculator. What's the actual time? 3 rad 2 divided by 2 ends up being 2 point. Good. 1, 2. Got pretty close just by. But it would have been so much easier just to kind of solve. So all of a sudden, kiddos, with parametric, we have some new things to think about. We're thinking about vertical as its own totally separate thing, dependent on time. We're going to think of horizontal as its own totally separate thing, dependent on time, and put the horizontal, the x's, and the vertical, y's, together to make points, which will still have paths. So what's new in parametric? Well, first we have this t thing. T's show up, time. Second of all, we have two pairs, we have a pair of equations, two equations for each one parametric function, x's and y's. Third of all, we have this new thing in our window called t-step, and t-steps, or t-min, t-max, I should say. T-mins and t-maxes tell us when to start and when to stop graphing. That's new. But let me show you one more thing. T-step. Sorry, I was just saying that, and I didn't actually show it to you. What if we're like, oh, we're geniuses. Now we know how to make it hit. Now we know to do 3 rad 2 divided by 2. Like, we got this. It's going to hit the ground. I'm going to see it. It's going to be gorgeous. Here we go. Dun, 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 dun. Ah! What happened? My math told me it was 3 rad 2 over 2. It's supposed to be hitting the ground. Why is it not? But here's the funny thing. If we were to do trace, and if we were to plug in, let's check it. 3 rad 2 over 2. Why does it show 0, but it doesn't show 0? Why does it show 0? Like it should work, but it doesn't actually hit. I plugged that into my calculator, but what does this t-step have me going by? Step. What's a step mean? Right? Okay. When you have this in your calculator, the x scale and the y scale, isn't that like the tick marks that the graph is supposed to put it in its function? And then the graph is the graphing calculator. The programming is saying, okay, I'm going to put a point here, I'm going to put a point here, I'm going to put a point here, and I'm going to connect them for you. And you're like, cool, thanks. But when we're in parametric mode, the t-step says exactly which points to plot. So to make this a little bit easier, a little bit simpler, let me go ahead and change this to just be point ones. And if I had this just go by point ones, let's see if that fixes anything. It still doesn't hit, and here's why. The graphing calculator, when I have the t-step at point 1, says, okay, I'll go by point 1s. Point 1, point 2, I'll put a point, point 3, I'll put a point, point 4, I'll put a point. It's going to go all the way up until, what's the upper bound? T-max is? 2.1. Okay, so it's going to graph 2.1. It's going to graph 2.1. But it's not going to graph any further. Why? If it's going by point ones, what would be its next step? 2.2. But, it's not supposed to go that far. So it goes up and it graphs to 2.1, then it stops. And it's like, well, I can't take another step or else I'll be outside, so I'll just stop. So how could I make my grapher show me the water balloon hitting the ground? What if I were to go by 0.01? Or even better yet, 0.001. Ha-ha! Now it's going to hit the, where is it? What's it doing? Like, give it some time. Now it hit the ground, right? It did so many more points, and now it's able to say, okay, now I can show it to you because I'm allowed to take the steps. I'm allowed to take the steps to show you. The t-step? Well, here's the problem. If you do t-step of 0, that's the distance of the steps. So you're saying go from here to here with 0 steps. You're like, see what I mean? So it's confused. As long as it's a number, Rachel can do it. Now, when you do something really weird, like what if you do 3? Why is that weird? You're like, you missed the whole graph. The whole thing's gone. What's going to graph? Nothing. Why? Because you didn't let it take any steps in the legal range. Now, what if you did something like, okay, I get it, 3 is too big. Whoa, no idea. What if you had to go by ones? Will it get a couple points in? Yeah, I suppose. It'll get a couple points in. It can do 1, it can do 2. So it's going to do 1 and it's going to do 2 and connect them. It's not going to show all the in-between points because you didn't let it do the in-between. You said graph, graph. Okay, cool. So the mode is very funny, very finicky, very fickle in the sense of if you're not very nice to it, it's going to get kind of mean. But if you just do zoom standard, if worst comes to worst, you can reset zoom standard. That resets everything. Then you can go ahead playing with your zoom, making the X's be big enough and the Y's be big enough, and the T's are now back to something normal. And then you can go ahead and play again with, okay, everything's redone and I'll start again. But when we were doing the whole 2.12 yada yada yada, the 0.1 wasn't super hot. We might want to go 0.01. The more steps, the more accurate. Okay, that's just playing with your calculator. Let's start playing with the actual parametric stuff and talking about the actual graphing and how it works, and not just the calculator. The calculator is just a tool. P.S. 10.6 is all about par mode, the second mode, function then par on your calculator. 10.7 is all about polar mode. That's the third mode. 10.6, this one, we're using T's. 10.7, we're using thetas. We're just introducing them. We're not going crazy in depth. Basically, before you leave pre-cal, I want you to see these two modes and at least just get a little scratching of the surface, just a little tiny peek at polar or parametric. They aren't huge ideas in Calculus AB, Calc 1. They come back in Calc BC, Calc 2. But then parametric also come around when you're doing physics. But once again, we're not going to spend tons of time on them. We're not going to go crazy in depth. We're even skipping like section 10.8 entirely. We're just introducing parametric, introducing polar. Getting a couple homeworks and then a quick quiz on them. Okay, if you guys haven't noticed yet, which most of you did because you're playing with your calculators, there's going to be an X spot and a Y spot as far as putting functions. There's going to be an X spot and a Y spot as far as putting functions. So X is going to have a function of T's, Y is going to have a function of T's. Each of them defined separately in parametric. I'm going to call this thing called a planar curve, what happens when you graph in polar. I'm going to call it the path. Usually we're talking about things that are moving along a certain path, so then I can call that planar curve like the path itself, that the object, the car, the particle, the water balloon, the path that it's traveling on. But the snazzy name is the planar curve or the plane curve. And that would have been like the parabola on the page before. Now, since this is a new mode, like super new, like you guys have been working in function mode ever since like middle school math. Ever since you learned X and Y, you've been doing X's and Y's and X's and Y's and X's and Y's. And now all of a sudden we have X's and Y's and T's. And you're like, huh. So, the very beginning when you guys first did X's and Y's, didn't you always make tables? Very beginning, before you memorized like the standard forms of lines and standard forms of parabolas, before you learned what trig functions were, or exponential or logarithmic, and how to figure out their movement, their swoops, their asymptotes, their behavior, their concavity. Before any of that, you just made tables. So we're going to go back to the very beginning and say, okay, let's make tables with parametric because we're not so hot at them. They don't come naturally to us because we literally just learned that they're a thing. But if we're making a table for a parametric, we don't just need x and y, we also need t. And believe it or not, x and y, neither of them are dependent. Sorry, neither of them are independent. Both of them are dependent on this new guy called t. So t is our independent variable, not x. Which kind of makes sense if you think about motion. Time is the key. Time has to pass in order for motion to be a thing. If time is stopped, well, no motion can happen, right? Now, why do you think I'm going to normally start my t's at 0? Why does that make sense? Starting point, exactly, at the beginning. And at the beginning, we can say time is 0. So let's say right now, 12:01. Time is 0. Could there be negative time? Okay, good. Thank you. Okay. Right now, 12:01, 12:02. Time is 0. Could there be negative time? No. Why not? What about 11:58? Wouldn't that be negative time from my 0? Could something have been going on at 11:58? Yeah, so I could have negative time. Now, does that mean I'm going back in time? No, not necessarily. Maybe I'm rewinding, maybe I'm... So there are different ways of thinking about negative time. So there could be negative time. I'm not saying it's impossible. But usually if we're starting off with some sort of motion-y thing, usually we say time is 0 and then it goes from there. So we can go time is 1, time is 2, time is 3, etc. Okay. Time, another important thing about time, which is going to come right here with the word orientation. Time, for our purposes, will only go one direction. Time only goes forwards, not backwards. So therefore, as we're graphing points, we're never going to go like backwards with time values. We're always going to go forwards. And we're also going to always connect points going forwards. We can't just kind of like we do with x's and y's, plot a lot of points and be like, oh, connect them in any order. It shouldn't matter. It's very important with parametric that you connect in the order of the time increasing. So let's go ahead and go do an example of graphing with the table by hand, not using your calculator. I know your calculator's out. You can check it with your calculator, but first of all, just old school. We have a table. The only new thing is we have x and y and t. Plugging in these t's, -2, -1, 0, 1, 2, 3, etc. I want you guys by hand, plug them in, get x's, get y's, and when you get your x's and y's, for instance, let's just do one. If we plug in -2 to the x, wouldn't that be 4 minus 4 is 0? And when we plug in -2 to the y, wouldn't that be -1? We're not going to graph the t. All we're going to graph is the x and the y. So we're going to come over here and say, okay, when t is -2, okay, whatever. That's when this is happening, but what's happening? Well, this object, this particle, this car is at the point 0, -1. So 0, -1. There we go. 0, -1, there we go. So how do you know where else to go or where to go next? Plug in -1, get a point. So the t's are what we use to get the x, to get the y, but then you just graph old-fashioned, what is the x, what is the y? Okay, the t doesn't show up on the graph at all, besides just saying, hey, it's legal to graph him because he's one of the t's in the situation. All right, finish the table. Graph the points. Try to connect the points to show me the path that this object is on, and try to figure out what I mean by orientation. Let me give you guys a couple moments. Go. of you guys are student council candidates? Just so you know. Okay. You're supposed to technically leave early, so just keep an eye on the clock and if you can finish. Okay. Have you guys kept on getting points? Yeah. Did you guys get points? Okay. Does that match up with kind of what you got? Now, what did you guys do with those points? Good. So then we could have graphed our -3, -1/2, -4, 0. Now, does anybody think it was kind of weird that this seemed to double back in on itself? Like, we never graph non-functions. I mean, I guess we kind of do with sideways parabolas and things, but that's not usually a thing we can put in our graphing calculator. Then we go to 0, 1, then we go to 1, 2, 3, 4, 5. Did you guys connect it in this little kind of sideways parabola graph? But here's a question. Was the object on this path, according to time passing, was it moving to the left and then to the right? So is moving up and to the left and right, or is it moving down to the left and then right? According to the time, which way should I put arrows? If you guys didn't notice, there were arrows on this parametric graph. Maybe you didn't pay attention. There were little baby orientation arrows. Little baby, hey, this is the movement of the particle, because it could go one way, or other equations could have it go backwards. That's something new in parametric, what direction it's graphing. So, which way should it be going? Up and to the left. Good. So orientation arrows, this is how you finish a parametric graph. You put little arrows saying, hey, it's headed this way. And that's exactly what it's doing. Orientation just means, hey, show the arrows of the motion, because another set of equations, well, let me show you. Another set of equations might have this exact same path, but be moving either A, at totally different speeds, or B, in a totally different direction. So, for example, right here, different parametric equations. If you guys look at these, it's the exact same path. It's the exact same locations, the exact same x's, the exact same y's. It's the exact same path, but I'll say different timing. Because first of all, this guy is starting earlier. He's at the start line at -2. He's at the start line at like 9:58 and starts the race. This guy's at -1 or 9:59 starting the race. So this guy starts first, but who finishes first? Takes this guy 3 until 3 to be at the end. This guy's already at the end at what point? 3/2. So who finishes first? This guy. He starts behind. He starts a whole second off of that one. And he goes faster and passes him to finish. So both of these, same path, but different equations showing different timing. That's something new in parametric also. But even though that timing is important, and even though parametric is super helpful for timing, starting and stopping and directions of movement and paths and how fast they're going, there are times when our brains would kind of just rather either find the path, know the picture and not have to do the whole table-y thing with t's and x's and y's, or just the directions, say, eliminate the parameter. Say, hey, forget t for a bit. And you're like, I can't forget t. He's a really important guy in parametric. Well, if they're telling me to eliminate the parameter, to get rid of t, eliminate, take out t, there must be a method, there must be a way to say, all right, fine. There must be a way to ignore the time, to get back into function mode. Basically, it's converting parametric to function. And the conversions say, step 1, isolate t and x of t, aka get t by itself, which I can do by saying times 4 times 4. Step 2 says take that, after you get t by itself, take that value, take what that expression for t, and plug it in to the y. Take the x expression, solve for t, take that expression, plug into y, and say, ha-ha, t, you're gone. Why? Because he's been plugged in for, he's been substituted. So now y is equal to 4x quantity squared, which means, what path is this guy traveling on? 16x squared. That's the path. Now, do I know the starting or ending? No, I got rid of t. Do I know how fast or at what times he's at different places on the path? No, I got rid of t. But do I know the path? Yeah. The path is going to be 0, 0. Go over 1, go up 16. Go back 1, go up 16. I know my path, just all the timing's gone. But that's okay. Sometimes it's helpful to be able to see what the parametric equations, what path they're traveling on. But if we need to know anything about timing or anything about how fast or anything about starting and stopping, well, then the parametric is more useful. So we can go back and forth between rectangular and parametric, parametric and rectangular. We just have to follow our steps. So what do you guys think we'll do to eliminate the parameter of this guy? What do the steps say to do first? Isolate the t in who? In the x. All right. Just got harder. But that's okay. Just think about algebra. What would you guys do? How would you try to get to t? Yeah, I like that idea. Square both sides. That square root's messing everything up. 1 squared. Square root squared. Just itself. Now what? Have you guys learned from me yet? If you have division and something's stuck in there, you always undo by multiplying. So if I multiply times t plus 1, if I multiply times t plus 1, can't I divide x squared next? Hold on. Can't I then divide x squared and subtract 1? How would I finish? What's step 2? There we go. Good thing is we still have a half day tomorrow to finish up these last couple examples, so you're good. No. In our class, I said we take a day and a half on this. So we have a half of our class period that will cover this, and the second half will go to 10-7. All right, cool kids, this homework isn't due till Monday, but I would start it tonight. Pep rally schedule, go vote for your student council. Seniors, you have an extended lunch.